All right, guys, we are in Algebra 2, Mod 8. Today is Tuesday, April 7th, 2020. The title of today's topic, you probably guessed it, it's adding and actually also subtracting rational expressions. Remember the last few days, we have simplified rational expressions. We've multiplied rational expressions. We've divided rational expressions. Now we've got to add and subtract them. And this is on top of all the rational functions that we graphed last week. So today, again, as always, please focus and pay attention and try to learn something here. You're going to take notes as if you're in class. Top left corner, today's date, April 7th, 2020. Title again, adding rational expressions. Divide up your paper, and all we're going to do is 4 problems together. Again, a 15-minute learning session. Pay attention, take your notes, think along with me, don't just copy, and try to understand the steps so that you can then attack the problems and see if you understand the material. Okay? All right, problem number 1 says x minus 2 over x plus 4 plus x plus 3 over x minus 5. Oh boy. Okay, take a look at this. If this was a times sign or a divided by sign, we would not have to worry about a thing called what? Common denominators, remember? Because when you were multiplying or dividing fractions, you simply factored and tried to cross-cancel things that matched up, and you simplified, and that was the main idea behind our last couple of days of notes. Now we've got an issue, which is why this is always saved for last, because it's a little more detailed than what we've done the last 2 days. Guys, notice there's a plus sign in the middle. I'm trying to add together these two fractions. If you go back to middle school math, 6th, 7th, 8th grade math, you were taught you can only add 2 fractions if they what? Finish my sentence. If they have a common denominator, right? Well, this denominator on the left does not match that denominator on the right. Agreed? So guess what? If you're going to add these fractions together, I'm going to have to do the following. I'm going to have to multiply the first fraction by the second denominator, and then I'm going to have to multiply the second fraction by the first denominator, because again, they don't match, do they? So the only way to get matching common denominators is to multiply this first fraction by x minus 5 over x minus 5, and multiply the second fraction by the first denominator, which was x plus 4 over x plus 4. Okay, so far so good? Now notice the 2 values at the bottom of this first fraction now match the 2 values here on bottom of the second fraction. So the denominators are the same, and I can add all this together and get one fraction whose common denominator is, of course, an x minus 5 and an x plus 4. That's my common denominator. Problem is, you got some work to do up top. Agreed? Look at this first situation that I'm pointing at right now with my pen. I've got to take this x minus 5 and times it by that x minus 2. Agreed? So I'm going to have to double distribute. X times x. X squared. X times negative 2 is minus 2x. Negative 5 times x is minus 5x. Negative 5 times negative 2 is plus 10. Plus, oh, there's still a plus in the middle. Now I got to go over and take this guy, x plus 3, and times him by that guy, x plus 4. Agreed? They have to be multiplied together. So double distributing x times x, x squared, x times 4 is 4x, 3 times x is 3x, plus finally 3 times 4 is 12. And you can now tell my last step, isn't there a bunch of terms up top? I'm going to combine my like terms in my numerator and leave my common denominator as is. So my final answer is not as bad as it looks. It's just kind of detailed. Agree that if we combine like terms, I've got a 1x squared plus another 1x squared for a total of 2x squared. I'll kind of cross those out since we've just added them together. I got a negative 2x and a negative 5x, which is a what? Negative 7x. Oh, but this is a 4x plus a 3x, which is a positive 7x. So do we agree that all the x's end up canceling on those like terms? And so all I've got left is a 10 and a 12, which of course would be plus 22. All over. And then you've got those two guys on the bottom still serving as my, quote, common denominator. And since I've added everything together, I've got my simplified answer. Now, notice up top, you could have factored out a 2. But if I would have factored out a 2, wouldn't that just leave me with x squared plus 11, which would not cancel out with one of the factors on the bottom anyway? So when you get to this point, you're pretty much done, since nothing is going to cancel if you did move forward one more step. Okay? All right, let's go to number 2 here. Oh boy, it says 4xy over x squared minus y squared plus x minus y over x plus y. Again, there is a plus sign in the middle. I'm adding two fractions. My denominators are not the same. Careful here. Kind of similar to what we did the last couple of days. Everybody look at this first denominator. Okay, look at it. Isn't that the difference of two squares? If that would have said x squared minus, let's say, 9, wouldn't you have wrote it as x plus 3 times x minus 3? So this denominator here, since it is a difference of two squares, I'm going to change it into x plus y times x minus y. I factored it. Excuse me. Does everybody agree that that's x plus y times x minus y? Oh, so now when I compare my two fractions, this second fraction has an x plus y on bottom, doesn't it? What does it not have? It doesn't have that x minus y right there, does it? So I got to multiply that by x minus y over x minus y. The first fraction, I don't need to multiply by anything because it already had both of those things on the bottom. So does everybody agree? Look, this denominator now matches that one right there. So since the denominators match, I can add all this together, make one fraction whose common denominator has an x plus y and an x minus y. Now up top, that 4xy didn't have to get multiplied by anything, did it? So it's still sitting there just as it was. Plus, now here, again, I'm going to take this guy and times it by that. I got to double distribute again. X times x, x squared. X times negative y is minus xy. Negative y times x is another minus, might as well write xy instead of yx, right? Keep the xy in that order. And a negative y times a negative y is a plus y squared. Basic algebra, you just have to concentrate. So does everybody again agree that if I now take the numerator and combine all my like terms, I've got x squared. Now watch this. I have a 4xy minus 1xy minus 1xy again. So 4xy minus 1xy would give me 3xy. Minus 1xy would give me 2xy plus y squared all over these two guys down here on the bottom. Now, interesting to note, if you took this numerator and tried to factor it, Now, why am I even thinking of that? Isn't that a trinomial, guys? Oh, so x squared would be what? X and x. I have a plus at the end, so my signs are the same, both pluses. And y squared would be y and y. Oh, so notice it actually did factor correctly. And now that I factored it, if I look at the bottom, which had these two values here, this x plus y and that one both cancel, giving me a final answer of x plus y over x minus y. So, oh boy, I'd put a star by that one. Things are getting a little tougher here as we approach the end of our unit on rational functions and expressions. That's probably the hardest one of today's group. Stick with me, stick with me. Number 3 here. If I look at number 3, there's a minus sign in the middle instead of a plus sign. First of all, we need to fix that problem. Isn't the rule when you do a subtraction problem, change subtraction to addition and change the sign of the next number? Because in essence, that's really a -1 that's getting distributed to both of those values up top. So guys, what we're going to do here in our first, we'll call this a cleanup step. We're going to change subtraction to addition, and we're going to change the sign of this next number. So that'll turn into a -x and a -3 here in a second. The other thing I notice is down below on this first denominator, can't you factor out a 3? And down below here, can't we factor out a 5? So calling this just a let's clean this problem up kind of step here, I've got x minus 1 over factor out a 3. It leaves you with x plus 5. I'm going to change subtraction to addition. And that minus gets distributed, changing the numerator to -x minus 3, because he gets distributed to both. And down below on the second fraction, of course, look at it, you can factor out a 5 and get x plus 5 as well. So what's the good news? There's an x plus 5 here. There's an x plus 5 there. The only difference between these denominators, this guy has a 3, this guy has a 5. Oh, so I got to multiply this by 5 over 5 and that by 3 over 3. Because now, do you agree? Look at the first denominator. 5 times 3 is 15 and an x plus 5. And over here on the second denominator, 5 times 3 gives me 15 with an x plus 5. So my common denominator is 15 with an x plus 5. And up top, okay, careful, I've got this x minus 1 dot connected to a 5. Distributing, I have 5x minus 5 plus, now I take this numerator and I times it by 3, right? So distributing him, I get -3x minus 9. I finally take that numerator and combine like terms. So it looks like when I combine my like terms here, I'm going to get what? 2x minus 14 over 15 times x plus 5. Now, I am going to circle that with confidence. Yes, I could factor a 2 out of the top, agreed. But doesn't that leave me with x minus 7, which doesn't cancel out with the x plus 5 on the bottom anyway? So we're done right there. Okay, you can do this. It's not horrible, it's just detailed. You've got to focus one step at a time. Finally, last problem, hang in there. Oh, looks like this. It's pretty obvious. Okay, once again, that does say minus in the middle, doesn't it? And you look at the first denominator, you see a trinomial. You look at the second denominator and see a trinomial. So does everybody agree when we do our cleanup step here, we're going to go 3x over, factor him into x and x. Plus means my signs are the same, right? Both minus and minus. And we'd use what? 5 and 2. I see a minus sign. We just got done saying on the last problem, you change subtraction to addition and change the sign of the next number. So that next number is going to change to negative 2x over, and I'm going to factor that denominator. Agreed? X squared would be x and x. I have a plus at the end, so my signs are the same, both minuses. And I use 5 and 3. I'm comparing and I'm praying to God that those two denominators are exactly the same. Well, guess what? They're not. The question is, how are they different? Well, they obviously both have an x minus 5, don't they? What does this first denominator not have that the second one does? Well, he doesn't have a what? An x minus 3. So I multiply him by x minus 3 over x minus 3. What does the second fraction not have on the bottom? He does not have a x minus 2 over x minus 2. So, oh my goodness, when I add all of this together, my fraction will have as a common denominator all three of those binomials, correct? My common denominator is x minus 3, x minus 5, and x minus 2. Now up top, don't panic. I'm taking this 3x, I'm timesing it by x minus 3, right? So I distribute, get 3x squared minus what, 9x? Think with me. Plus, in the middle I have plus sign still. Now I'm taking this negative 2x and distributing him, right? Because he's being timesed by the x minus 2, giving me negative 2x squared. Careful, a negative times a negative is a plus 4x. And when I combine like terms up top, 3x squared minus 2x squared would be what? X squared. A minus 9x and a plus 4x, when I combine them, is minus 5x over all three of those guys on the bottom. Uh-oh. Don't circle that. What do you notice about the numerator? Can't you factor out an x? Leaving me with x minus 5. Oh, and notice the denominator does indeed have an x minus 5, doesn't it? Those will cancel. I did it. That's kind of our grand finale here. Put everything together. My final answer should be just an x on top with x minus 3 and x minus 2 on bottom. Wow. Now that's good stuff. That's Algebra 2. That's the type of stuff you'll see in college algebra. Mr. DeMarco's kind of ending the chapter or the unit with that type of problem. And I hope that makes sense. Again, common denominators are needed. You got to focus on the details and concentrate as you work your way through it. Okay? All right, got to give this a shot. Your 4 homework problems. I think you can see them all on the same page here. Again, we're in Algebra 2 Mod 8. Today is April 7th, Tuesday, April 7th. So this assignment, these 4 problems, you got to sit down and take your time and work them out, circle your answers. It is due by noon on Wednesday, April 8th. This is probably your toughest assignment yet during our distance learning. Guys, I'm telling you one time here, you are not going to do this problem, show your work, circle your answer, send a picture to your friend who then copies your work onto his paper and then sends me a picture of his work as his homework assignment. The second I find out for sure the people that are doing that, we are going to have some issues. Please do your own work. If this is going to be done, it's got to be done correctly. Please, I'm asking you, have some character and some discipline. Have the goal of watching the video and trying the problems on your own, and send me the picture of what you get done. It's just a point or two if you miss a problem or two. Your job is to try the best you can and learn the material by doing things honestly in the right way. Do not make this turn into something that we're going to have some big issues with and involve parents and principals and everything else because kids are cheating. You're doing your own work, sending me a picture of what you did, not what someone else did. Okay? Those of you that are doing things the right way, thank you. You're doing a great job. Here's your homework for tonight. You've got 1, 2, 3, 4 problems that literally mimic the 4 I just did. So give it a shot. That's due tomorrow at noon. And again, you're doing a great job for the most parts, and we'll see you tomorrow on Wednesday, okay?